So converting mass and length are two ways that we can convert metric to imperial units using our base units, but we also have derived units that we use. And so now we're going to be doing some conversions and looking at what happens when we have a derived unit. Volume, as you know, is a derived unit. And I say as you know because you guys know that volume is base times width times height. So when we look at a cube, this is where we're looking at our volume. We have a length, a width, and a height. Okay, so we have length, width, and height. And so we can combine those. Let's say this is a centimeter, this is a centimeter, and this is a centimeter. So that's a centimeter times a centimeter times a centimeter. That is a centimeter cubed. That is the definition of a derived unit. We also then can use the density of water. You don't really need to understand why, but we can change this into another unit called a liter. So the first thing we're going to do is we're going to look at how we can exchange imperial and metric conversions for volume. So you may know that in our imperial system, we use the US gallon to measure volume. So we're going to be doing conversions between the US gallon and the metric liter. So let's start with this first one and we'll do it together. This is asking how many liters are in a 5-gallon Sparkletts bottle. Just for the record, as you're trying to think about liters, don't forget about your 2-liter soda. Okay, that soda bottle that you buy for a party, that is a 2-liter soda bottle. And so when you're thinking about, well, how big is a liter, at least you'll have a point of reference. That's 2 liters in that one container. So we're going to start with a 5-gallon, gallon is abbreviated gal, a 5-gallon bottle. And we're going to be converting to liters. So we're going to put gallons on the bottom and liters on the top. 1 gallon is equal to 3.786 liters. And so all this is a matter of is multiplication. So we're going to do 5 times 3.786 and we get 18.93 liters. And it makes sense when you think about how big a 5-gallon container is. If I pictured picking up a 5-gallon jug of Sparkletts, it's a pretty good lift. It's a pretty big container versus a 2-liter bottle of soda. So it makes sense to me that there would be a big number of liters in that big 5-gallon jug. And so you want to do that does it make sense test. You want to ask yourself, is this a rational answer? Okay, so this time I want you guys to try this challenge. So we're starting with 750 milliliters and we're converting to gallons, but we can't go directly there, right? Because we only have liters to gallons. So we're going to start with our 750 milliliters. Oops, I forgot to erase. So we're going to be converting our 750 milliliters to US gallons. This is going to take 3 fractions if our first fraction is what we're given as a fraction over 1. The next thing that we need to do is move our milliliters to the bottom. Now this is something I'm going to teach you later on in the semester, but I'm going to front load it with you guys right now. We know that we want our answer to be in gallons. And so knowing just what we know right now, that allows us to know that this last top numerator of the fraction also needs to be gallons. Gallons converts to liters, right? So I can put liters down here. And then I can use the reverse process of canceling and say, well, if liters is down here, that must mean that liters is on the top or is in the numerator of my second fraction. The reason why I'm showing you this is sometimes we get to this point and we feel stuck. And I don't want you guys to feel stuck. When you're thinking, man, I'm feeling a little bit stuck, I want you to think, well, what's at the end and can I work backwards? And oftentimes what happens is we're able to meet in the middle. Milliliters to liters, this is a lookup on your chart. So I'm going to give you guys a second and I want you to tell me, what is the conversion factor from liters to milliliters? Great. So 1 liter is equal to 10 to the 3 milliliters or 1,000 milliliters. And then we put our conversion factor in for gallons. So 1 gallon, 3.786 liters. And this one is a little bit of a math issue for us. So we're going to do the math a little bit slow here. We're going to start with 750, and I'm going to divide 3.786 because PEMDAS, or please excuse my dear Aunt Sally, allows me to do my division in whatever order I feel like it and still get the right answer. So I'm going to start with 750 divided by 3.786. And I get 198.098 or 198.10. So I've rounded it off to my 2 decimal places, but I can't forget this. And now I'm going to divide by 1 times 10 to the third, which is really what this is, 1 times 10 to the third. And I'm going to end up with 0.1980. Now in science class, we like to have the number in front be bigger than 0 but smaller than 10. So I would like 1.98, and then I'm going to round that off because I want my 2 decimal places, times 10 to the negative 1 gallon. Now there are 2 easy ways to get to this exact answer. This would be the one that gets you full credit on the test. The first way would be to know that to move the decimal place 1 that way, I need a negative 1 there. Because in order to take this out of scientific notation, I want to move left. And if I want to move left to take it out of scientific notation, then my exponent needs to be negative. The other way to know it, this is the easier way, is I'm just going to take my calculator that's not in scientific notation, and I'm going to say mode, and then I'm going to go select psi and hit enter so that it's in scientific notation. And then if I plug it back in and I say 750 divided by 3.786 divided by 1 times 10 to the 3, and I end up with 1.98 times 10 to the negative 1. So what you might want to do if you're not feeling super confident in your moving the decimal place, changing the exponent skills, is to make sure your calculator's in scientific notation. It's a really easy fix to keep your life nice and simple. You guys are at home learning this, which means there's no reason that you shouldn't be able to use your calculators during the test. You can't forget it. And since you're going to have your calculator during the test, you shouldn't need to know how to do the moving of the decimal on its own. Really, you should be able to use the calculator in order to do that for yourself. In our next section that we're going to cover, we are still looking at those derived units from the metric system, and we're still looking at how we can use those derived units. Now for density, we're not going to be doing converting. We're actually going to be doing solving.